Good evening, welcome to Videos Online Academic Tutorial. Thanks for watching our videos online. Please, if you have not yet subscribed to this YouTube channel, please do well to press the subscribe button now and the notification bell in order to see all of our educative videos online. Please help us to make this channel know in order to be able to serve more people better. Thank you and God bless you. Amen. First questions we are having here is that write the structure and the impact name for one alkanoic acid with molecular formula C4H8O2. We are asked to write the structure and the impact name for one alkanoic acid. Note the word alkanoic acid with molecular formula C4H8 and O2. Now let's go to the answer from the word to the answers. So let's solve the question is before us. Now the first thing is what we are asked to write the structure of C4H8O2, and this is the molecular formula for the what for this compound, and we are told that that compound is an alkanoic acid. We are told that it's an alkanoic what? It's an alkanoic acid. Now you need to understand the functional group. You need to be able to identify the functional group that will be in this compound, because from the word alkanoic now it means that that compound has a functional group of COOH. So this is the functional group for alkanoic acid. I'll quickly brush through all the functional groups that we have in organic chemistry. Number one, the functional group that we have in the functional group that we have, the name of organic compound that we have, and the functional group present in them. The functional group that will make the functional group, that is what their identity, what are the things that we will see, what are the molecules that you will see that we will know that this belongs to a family of alkanoic, it belongs to a family of what? Alcohol, or family of what? Alkene what? Or alkene, and what? So whenever we have alkane is a saturated hydrocarbon. Saturated hydrocarbon means hydrocarbon with single bond. So hydrocarbon with what? Single bond. So let me just so we are going to have what? We can also know whether it's saturated or not. So saturated means whether saturated or saturated. Saturated means that it contains single bond. Unsaturated means it contains multiple bond, whether it is double or what? Or triple. Now, alkane now is what? It has a functional group of what? C single bond. Then the molecular formula, the general molecular formula is what? CnH2n plus what? 2. CnH2n plus 2. That's the general molecular formula for what? For alkane. So we are still coming back to the question, but I want to outline the likely functional groups that you have to you have to meet in your questions in organic chemistry. So now we have what? The alkene. The alkene is C double bond, and it's what? An unsaturated hydrocarbon. You can call it this one saturated hydrocarbon. That is carbon with what? Hydrocarbon with what? Single. This one is saturated hydrocarbon. This is unsaturated. So now unsaturated we have what? CnH2n. So now we have what we call alkyne. Alkyne is having triple bond, which is C triple bond C. Also unsaturated. That is unsaturated. Now, what makes it saturated and unsaturated is this one is containing single bond, which is sigma. This one is containing sigma and pi. This one is containing sigma, pi. So that's why it's unsaturated. So the functional group is CH2A minus 2. So that is the molecular formula. So whenever you see compound obtained from this general molecular formula, CH2A plus 2, such as what? E.g., let me give an example. E.g., when you meet compound like C2H6, which is ethane, you can see when you put 2 inside this place, you are going to have what? C2H6. So, and this one, when you put 2 inside this one, becomes C2H4. C2H4. So that is 18. And this one, when you put 2 inside this one, we are going to have what? Ethyne. C2H what? H2. C2H2. So now, another thing that we have here before we leave the what? The hydrocarbon is another one that we call alkene. Alkene is usually a substituent. It's usually what? It's usually a substituent. We usually find alkene group to be substituents such as methyl, such as LT. They are usually substituents. They come from what? From alkene. They come from alkene group that has lost a hydrogen. So an alkene group is a compound that comes from alkene family, in which one of its hydrogen has been what? Has been lost. So what am I trying to say is it's also of a single bond. Alkene is also contain what? Single bond. And then the general formula is CnH2n plus 1. Now when you compare this general formula with this now, you can see this one is having plus 2, this one is having plus 1, indicating that group of what? Of hydrocarbon has lost what? Has lost an hydrogen. So that's why we have what? Alkene group. So now these are the functional group for what? For hydrocarbon. We call these ones hydrocarbon, including benzene. The group of benzene, we call it aromatic hydrocarbon. Also, that one is a ring what? Hydrocarbon. So now we call these ones hydrocarbon. Now, another functional group that we have here is what? Alcohol, which is known as alkanol. Alcohol is known as what? Alkanol. So alcohol is known as what? Alkanol group. So it's having COH. So this functional group that is having COH. So the functional group itself is what? OH. Hydroxy. So this hydroxy is attached to what? To carbon. So we call this what? We call it what? We call it, let me know this so I did not confuse you. So dash COH, that is C will be where. So this is called what? Alcohol group. So it has CnH2n plus 1 OH. Now this CnH2n can be represented as what? R as well. You can write it as what? It's the same thing as what? ROH, that is alkene group. So the alkana, I'm still going. Alkana is what? Alkana contains CHO. Alkana contains what? CHO. You can see very well. Alkana contains CHO. So this is alkana. So you have CnH2n plus 1 CHO. We call it aldehyde group as well. So this is what? Also we have the alkanoic, which is the one that we are asked to do now. Alkanoic, also known as, the common name is what? Carboxylic acid. Also known as carboxylic acid. Now, another name for alkanoic acid is carboxylic acid. Now, the functional group of carboxylic acid is what? COOH. So that's why I write it the other time here. That is alkanoic acid contain what? COOH. So when they say write the structure for this what? Write the structure for C4H8O2. It means that it must contain this what? This functional what? Group. So CN what? The general formula for CnH2n plus 1 COOH. Or you can write it as what? RCOOH. Where the R is an alkene group. You can write that this alkene, you can write it as what? as R, so that it will not confuse you. So now, and then another one that we have here is what? Let me very quickly list everything before I run to the word question. We have what? Alkene, also known as what? Esters group. These are group of organic. These are group of what? Organic compound. They have sweet what smell. Although a thing has slight sweet smell, but it's not that obvious. The organic compound that have a sweet smell, that has a sweet scent, is what? Ester group. Call it ester group. Alkene, esters. So the functional group of alkene is R. Here we have R COOR. So you can call this one first R, first alkene in the first front, and the other alkene in the second what? The second front. So if you want to write it in the general formula, we have H2N plus 1, H2CN, H2N, COO, CN, H2N plus 1. CnH2n plus 1, COO, CnH2n plus 1. So that's alkene. Now we also have what they call amino group. Amino group, we have amine. Amine, we have amine. Amine is NH2. This is amine. You can write that. You can put your R here and you can write CnH2n plus 1 plus 1 NH2, call it amine. Although we have primary amine, secondary amine, and tertiary what? Amine. But for one level here, amine is what? Amine. So we have what? The last one is amide. Amide is RN. Amide is what? Sorry. Amide is CnH2. It has what? Carbonyl combined with what? With amine group. Carbonyl combined with amine group. We have what? RCONH2. You can put, where your R is what? CnH2n plus 1 CONH2. So this is what? This is a list of what? This is a list of organic compounds we have. Now there's something I omit here. There's one that I ought to have wrote here. After alkene, we have something we call ketone. Alkene. I'll write it here. Alkene. Alkene. Here, this alkene is obtained as R. That is, there is one alkene in front. You can put dash here and put CO. Then put another dash. It means an alkene group is in front, an alkene group in the back as well, but they might be different and they might be the same. So one alkene group in the front, one alkene group at the back. You can now, you know that each alkene group can be replaced with CnH2n plus 1. That's the formula. So you can write it as what? CnH2n plus 1 in the front, dash CO dash CnH2n plus 1. CnH2n plus 1. So that is that. These alkene, also known as what? Ketones. This alkene is known as what? Ketones. So these are the list of what? The functional group and the molecular formula for that functional group, which we call the homologous series of every organic compound. So this is alkene, alkanone, okay, sorry, alkene, alkanone, alkanoic, alkanoate, amine, and amide. So these are the list. So I've written all the functional group that we have in what? In organic chemistry. These are the major functional group that we have in what? In organic chemistry. Now we can now go back to the what? The questions that we are considering before. So now we are asked to write the structure and the impact name for one alkanoic acid with molecular formula of C4 H8O2. Now that's the this is the molecular formula given to us for H8O2, and we know that we are to write it in what? To show what? To show that it's an alkanoic acid. You have to write it to show the functional group of alkanoic acid, which is what? Which is COOH. COOH. So how do we go about these words? These problems. How do we go about this problem? Let's just demarcate this one here. And we demarcated now. And box this one. Now, so to now write this one, now we have C for H8O2 as what? As an alkanoic acid. As an alkanoic acid which contains COOH. Don't forget it contains COH. You have to what? Show it as an alkanoic acid. So the first thing is to remove what? This COH out of it. And this COOH. I'll remove it like this. How many? If I remove COH now from this, the word I will have left now is what? I will have C3. Remove C from 4. It will remove C, one C from what? C4. So it will remove C3. Remove H from what? This, it will remove H from H8. It will be H7. So remove oxygen, 2 oxygen from 2 oxygen. So you can see that there's no oxygen left. So we can see this thing is forming something together. So if you combine this C3H7 with this compound, what do we have? You have something like C3H7 COOH. So if I want to name this compound now, I will call it what? Butanoic acid. So this is how to write it. So this is the what? The condensed form of it. Now it says you what? Write the structure. Write the structure. Write the structure. So this I have to show the structure. Now let's try to what? We are having C. How many C are we having? C3. We have C3 here, we have C here. So it means we are going to have 4C. We are having 4C. So we are going to have C, 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 C. And each carbon must contain what? Each carbon has 4 bonds. Carbon always has 4 bonds around itself. I've already mentioned the video on what? Why carbon has 4 bonds around itself. It's because of its valency electron. It has 4 electrons in Natable's what? Share. So now this carbon which is bearing the functional group, we have what? Look at this, have OOH. So the functional group is look like this. How you write it? C double bond O. This oxygen is taking double bond. Then this one is taking OH. They are just what to do. This is how you write it. If you want to split it very well, you can still split this one, but you can leave it like this. So C double bond OH. So now you are done with what? You are done with the functional group. Now it will mean what? C3H7. Now the first C. Now you know carbon must have 4 bonds around it. So we have this 1, 2, 3, 4. So this one has 4 bonds now. 1, 2, 3, 4. Now this one has 1, 2, 1, 2. So we put 1 to make it 4. This one have 1, 2. You put 1 on the top, put 1 on the down. So now you use hydrogen to fill up those empty spaces. Hydrogen, 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 hydrogen. If we count it, it will be 7. 1, 2, 3, 4, 5, 6, 7. So this is C3H7 COOH. So this is the structure. Are you following? So this is the structure. Now we have successfully write the word. The structure. Say write the name. Write the name also as well. This is the structure. But now you can also write it in another form, because there's something we call isomers. This is the first structure of what? Of this compound. But molecular compound can exhibit what we call isomerism. In fact, organic compound exhibit the property called isomerism. Isomerism is the phenomenon whereby a compound have same molecular formula but different structural formula. I come again. Isomerism is the phenomenon whereby what? A compound have the same molecular formula, but different structural formula. So now look at this is the first structure that we can write for what? for C3H7 COOH. Now let's say another way of writing this. You can remove what? You can try to remove this what? Try to exchange this one with what? With this. With this, let me use different marker. So now put this CH3 and bring it here and bring H here. You see, we have different thing entirely here. So we are going to have something like this. C, 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 O, or we can write it as straight if you want to. O, H. So now, O, H. Now, this one now, you will now bring this and write it here. C. That's CH that you remove here. C and HT. You add it here. You take it here and you put it underneath here. So now you now bring that H here. That H here now is now here. So we have, now this one has C, H now. That H that is there, you bring it there. And this is your CH3 that was here before. You have bring it there. So this is your CH, the former CH which you have brought in. So you can see that we just make sure that this one comes here and the other one comes here. So this is the same word. They are still the same. They still have the same structure, the same number of carbon, the same number of hydrogen, but their arrangement is different now. So now if I want to name this now, if I want to name this, if I want to name what? This, because this compound is now different from what? It's not different from what? This one is not different. So if I want to name this now, let me try and separate it. So now, this is the compost structure. You can see this is the first structure, this is the second one. This is the first isomers one. This is the first isomer, this is the second one. This is the second isomers. So if I want to name this one now, according to the word isomers now, I will just say, okay, how many C's do I have? 1, 2, 3, 4. Now this is 4, and number 4 is boots. Number 4, carbon containing 4 what? Organic compound containing 4 carbon have what? Have is called boots. Boots. Now number 1 is met, number 2 is et, number 3 is what? Pro, number 4 is boots. So it's having 4 carbon now. You have 4 right? Boots. Now because it's an alkanoid group, you can see the noic here. Because it's an alkanoid group now, you are going to write butanoic acid. Butanoic acid. Because when I say the boot acid there, butanoic acid. So that's how to name the first word. 1, 2, 3, 4. So it is 4 carbon, it is boots, and because it has a functional group of COOH, it is what? Butanoic. Now let's do it to do justice to the what? To the second one, which is what? Which is, now look at this now. This one is now having what? 4. Now we are now having substituent of CH3. And whenever you are having substituent now, we said alkyl group are usually what? Substituent. You can see this one is an alkyl group. Usually what? It is melty. Number 1, because it is in number 1. Melty. You know, number 1 is mel. So because it is belong to what? Alkene, it's now melty. So this one is a substituent now. So because it's a substituent now, this is the main functional group. And the main functional group has what? COOH. If you count this is the longest chain. 1, 2, 3. So it is 1, 2, 3 now is what? Pro. Now because it's having functional group of COOH, it becomes propanoic. So the parent chain here is propanoic. Now, why do we now incorporate this? Now, from the functional group, now you can't from the functional group. Now, you can't from the functional group, and actually you can't such a way that you have small number towards your functional group. For example, now, if I start from here, now this is number 1, this is number 2. If I start from here, if I start from bracket, my my substituent fall on number 2. But if I start from the front, this will be number 1, no, see number 2. Number 2. Are you getting analyzed now? But you have to what? In fact, I cannot start from the front because this is not where my functional group is. Because my functional group is here, now I have to start from that place. So now that's why I'm starting from functional group 1, 2. So this name of this place is not what? This is my methyl 4 on carbon 2. So this one will be 2 methyl propan. Don't forget that it's propanoic acid. So these are the 2 ways the structure of this compound can what written. So 2-methylpropanoic acid. What? 2. Arrange the following compounds in order of increasing boiling point. Arrange the following compound in order of increasing boiling point. That is what we got 2. We got 2. Arrange the following compound in order of increasing boiling point. In order of increasing boiling point. That is from lowest to what? Highest. From lowest to highest. Don't forget increasing boiling what? Increasing boiling point. Increasing boiling point. For what? Increasing boiling, that is from lowest to highest. Please, you have to know that. Now, which one has the least? Which one has the second? And which is the third? So now increasing towards increasing direction. So the first compound we are considering here is butane. The second one is butane. The second one is butanoic acid. And the next one is what? 2-methylpropane. Now when you look at it very well, this is butanoic acid. Butanoic acid. What does butanoic contain? If you draw it structurally, let me just do the drawing now. Butane is number what? Is what? Butane is but. Number 4. Met is 1. 2 is what? Is et. 3 is what? Is pro. 4 is what? But. So this is 4. So an N belongs to what? Alkene. So if I want to write this one, CnH2n plus 1. So because it is 4, C4, H, now 2 times 4 now, because my N is 4. So it is what? 8, 2 times that, 8 plus, sorry, this one is supposed to be 2 plus 2. So this one will be what? C4, 8 plus 2 is what? C4, H what? 10. I'm just teaching us how we can draw the structure without cramming. So boots is 4. I substitute to the formula of what? General formula for alkane because of the A and E. That's what suggests that it's an alkane group. So now C4 and I substitute what? 2 into the general formula of what? Alkane group. So then I get what? C4H10. So this is the molecular formula of butane. Now when I draw butane structurally now, butane has 4. 1, 2, 3, 4. Now how many hydrogen does it have? It has 10. So we know that each carbon must carry 4 bonds. So we have what here H. So that's carrying from 1, 2, 3, 4. So we put 2. Now, so this is the structure of butane. Now, as regards butanoic acid, you can see that this is noic, it's an alkanoic acid. It's an alkanoic acid. So we recall for the what? CnH2n plus 1 COOH. COH. Then write this so you can. So CnH2n. So CnH2n plus 1 COOH. It has the formula from the table. Now you know that in butanoic, but is 4. So the COOH has taken 1, it remains 3. So the 3 that remains is what we are going to put here. So we are going to have C3H, 2 bracket 3 plus 1 COOH. So we can now give us what C the H cell COOH. So that's how we get butanoic acid. And you have done the structure on the last question that we did. So it will be C double bond O H. So this one is H. Then we have what? H here. And we just put that H here. Hope you can see it from there. So there's another H here. So in structure. Now what about the propane? 2-methylpropane. And these 2-methylpropane, the parent chain of this propane. Now for 2-methylpropane, the parent chain is propane, and propane has 3 carbon. Propane has 3 carbon. 1, 2, 3. Now that's 3 carbon, and I know that it is ANE alkane. So it has 3 carbon. Now this substituent is on number 2. That's why it is what? 2-methyl. So I will just put my methyl here. This is my condensed form of methyl. Instead of me writing CH3 like this, instead of me scattering it, I can write it in a condensed form. So I write it, instead of me writing it in form of like this, instead of me writing it in form of this, so I now write it in a condensed form. So don't be scared about how do I get this. So it's the same thing as what? It's just the condensed form. So this is what? CH3 2. So you now feed the rest with hydrogen. So now, how do I do this now? How will I go? How will I progress from here? How will I proceed? Now, don't forget that we are dealing with what? Increasing boiling points. Which one has the lowest? Which one is in the middle? And which one has the what? The highest. So now, there is a principle of the boiling point that says the higher the what? The higher the molecular mass of the compound. There are 2 principles that affect boiling point. The higher the what? The molecular what? Mass. The higher the what? The boiling what? Point. That's one. That's another first principle. The second one is that, okay, the second one is what? The higher the what? The degree of the higher the what? The degree of branching. That is, the more you have branches in your organic compound, the lesser the what? The boiling point. Are you getting it? The higher the molecular mass, that is, the more you have what? Like 6 carbon now has 4 carbon. If you have 4 carbon compared to 5 carbon, and 5 carbon we have more boiling points than what? 5 carbon we have more boiling point than what? 4 carbon. So the higher the molecular mass, the higher the boiling point. The higher the degree of branches, the more you have branches, the what? The lesser the boiling point. And the last one is what? The presence of what? The presence of hydrogen bonding. Hydrogen bonding increases what? Increases the boiling what? The boiling points. Now, what does this one mean? Now, the presence of hydrogen bonding increases your boiling point. That is, whenever you have OH, so to say, in a bond, the boiling point increases. It's because the polarity also increases. Now, this is the first priority before first digit, because the presence of OH increases the what? So this is the first priority. So this is the first thing to consider first, because it's multiplied the what? The boiling point because of that OH. So the first one that will have the highest boiling point is this. This one that will have the highest boiling point. This one has the highest boiling point. So this one is the, because it has what? Look at this. It has OH here. Sorry for that. Suppose C double bond OH. C bond C double bond OH. So this one has what? The hydrogen, but there's an hydrogen bonding between O and H. So now this one has the highest what? The highest what? This one is will be number 3 because this one that has the highest boiling water point. Now compared to this now comparing this and this together now. Although this and this are isomers, they are isomers. Please don't forget the word. These are isomers. They are isomers. This is butane. This is 2-methyl propane. So they are the same isomers. But what differentiates them in terms of boiling point is that this one has branch. This one does not have branch. So because this one has branch now, what do we say? The higher the degree of branching, this is means degree of branching, the lesser the boiling point. So this one will be smaller than this. The boiling point of this one will be smaller than this. So this one will be number 2. This one will be number 1, the least. So the increasing now, this is number 1, number 2, number 3. So it means 2-methyl will be smaller, followed by what? To be lesser than what? Butane. Lesser than what? Butanoic acid. So that's that about increasing order. Forget increasing order. So that's that about that one. So please note it. Make sure if you didn't get it, rewind and listen over it again, and you get it better. So now this is the second one. Question has been dealt with. Now the third one is, let's see. We ask, give the reason for explanation. Already given to it because this one is what. Now the reason why is that propane has what? A higher degree of branch, so it has lesser boiling point compared to butane. While the presence of butanoic acid make the boiling point to be very, very what? High. The presence of the what? Hydrogen bonding butanoic acid. The presence of hydrogen bonding will make the what? The boiling point to be very, very what? High. So that's why 2-methyl is less than butane in terms of boiling point. The boiling point of butane is less than what? Butanoic acid. I think we have done that. So now let's move to the next question, which is question number 3. Ethanol was used to what? Ethanol was used for preparing gas X, which decolorize bromine water. It changes what? It changes the color of what? Bromine water. Identify this color, identify this X, and briefly explain it what? Preparation. Now, ethanol was used for preparing a particular gas S, and that gas S decolorizes what? Bromine water. And the only gas that can be obtained from ethanol and it will decolorize bromine water is what? Is ethane gas. Ethane gas. So that is number C, number figure 1. Now, whenever we use ethanol is C2H5O. That's where I get it. Go back to the table. The alkyl group, which is known as alcohol, is CnH2n plus 1. CnH2n plus 1 OH. When you substitute what? When you substitute 2 into this now, you get C2H5OH. That's how we get ethanol. This is ethanol now, which is ethanol. So this is the molecular formula. This is the general formula for alkyl. So now when you introduce what? When you introduce conc H2SO4, and you heat. Now when you introduce conc H2SO4, not water, conc H2SO4. Conc H2SO4 is one of the reagents I use to obtain what? Ethane gas from what? Alcohol, which is ethanol. So when you use conc H2SO4 and you heat, so there will be dehydration, removal of water. Water will be removed. Heat will remove water with conc H2SO4. So when you remove water, now what? This OH will leave and one hydrogen will leave. So when one hydrogen will leave, this one will be what? C2H what? H4. They come again. This, when you heat it, water will remove, this H4 will remove. So this OH will remove. This one of the hydrogen also, one hydrogen will leave. So OH will leave. So when it's both of them leave, it means water has been what? Has been removed. So we're having what? 4 hydrogen that is left here, which is H4, and we're having 6. So this is what? This is 18. Call this one 18 gas. It's a gas. 18 gas. It's a 18 gas. And this ethanol is a liquid. It's a liquid form. It's a liquid form. So when you dehydrate it, using corn H2S4, that is removal. Dehydration means removal of water. So it gives you 18 gas, and you collect it over water. This is what? Upward displacement. Call it upward. Collect it over water. Collect it over water. The gas will be somewhere here. And these are water. The gas will be here. So the gas will come out. So we collect it through upward displacement. So this is the laboratory declaration of what? Of it. So that's that about. So there is, we call it dehydration. What? Dehydration reaction of ethanol to give us 18 what? 18. So that's one of the ways of preparing what? 18. So give the reagent and the reaction condition for conversion of ethanol to this. Now, this is another reaction that we are asked to call them as well. How do we convert ethanol to this? You can see the ethanol is at the back of this. And you can see this functional group. Let's write. So how do we convert ethanol? How can we convert ethanol, which is CH2H5OH? How can we convert it to CH3COO C2H5? This our ethanol is at the back here. And if you note this functional very well, it is simple RCOO R prime. These are extra, and this alkanoid group esters. And if you want to name esters, we name it from the back. This is a T. This is a T because of it's coming from this ethanol. A T, and how many carbon does this one have? Okay, let's see. This one is C2. Sorry for that. This is C2. This is C2H5. So this is Ft. Now, this you call this one Lt from the back. We name ester from the back. Lt. This is Lt. Now this is carbon 1, carbon 2. That is Lt. Or 1 carbon with carbon 3. That is making what? Making 3. That is pro. Now this is 1, 2, 3. Pro. Now it is called propanoate because of the word CO. So we call this one propanoate. So if you combine it together, it will now be a T from the back, a T propanoate. That's how you name what? You name esters. So a T from the back, a T propanoate. Now, if I now want to get a T propanoate, it means that I must have alcohol that come from it. That's why I have ethanol. So ethanol come from what? It having 2 carbon. So it's just the difference is just OH. Now, what else I'm now going to have now is propanoic, because it is the reaction between alkanol and alkanoic acid that will give us what? Ester, propanoate. So it means that now propanoic plus ethanol will give you what? Will give me ethanoate. That's my ester. So now, how do I write propanoic? Don't forget, check your table. The formula for propanoic is what? CnH2n plus 1 COOH. That is what that is. Now, propanoic is what? Having 3 is number 3. So this COOH has taken 1. This COOH has what? Has taken 1. So it means to just put to the C2H. H what? 2 times 2 is what? Is what? 4 plus 1. C2H5 COOH. This propanoic acid. You can see 1, it has 3 propanoic plus ethanol, no ethanol. Yeah. Definitely you will have what? You have your, what we have ethanol, which is already here already. C2H5 COO. C2. So now, what are the reagents? Propanoic and ethanoic. Now, in the presence of what? In the presence of what? H2SO4 or any acid that you can, any acid, any mineral acid can be H2SO4, HCl to speed the reaction or to allow the reaction to occur. Rather, so you use a presence of what? H2SO4. So that's that about number 6. So let's move to the next question. Question D says that state the type of reaction involved in each of the conversion indicated below. State the type of reaction involved in each of the conversion indicated below. Now, what are the conversion indicated below? We have the first reaction here is what? 6,6H6 to give what? 6,6H5 CH3 is an hydrocarbon, but this is an aromatic hydrocarbon. 6 is an aromatic hydrocarbon. It's an aromatic hydrocarbon, and actually it looks like this. That is benzene. Look like this. This is the ring form. If I have to split it very well, this is the ring form. I have to split. So we have C here, we have C at the top, we have another C here, another C here. So that it can contain it very well. So this one is another C. So we have double bond here, another bond here, another what? Bond here. So these are other way you can write this one. And you want to feed the hydrogen, and hydrogen will be. These ones are already have for 1, 2, 3, 4. So hydrogen, one hydrogen, another hydrogen here, another. So this there is C here. Don't forget that there is C here. There is C here with double bond. So we have what? Another hydrogen here, another hydrogen. So see, so this is this, and this. The form of this, these are this and this are the same thing. And this one does not show you what hydrogen and the carbon, but this one shows you what hydrogen and the carbon. So it's a method of arrangement. We have the name that we call it the chemistry, but there's no way for your own level now. So let's just, so we can write it as this. Now, what happened here is that the substitution reaction, we have replaced this hydrogen. One of this hydrogen, this you can see this 1, 2, 3, 4, 5, 6. One of this hydrogen has been replaced, has been substituted with what? With methyl. So instead of this what? Instead of this now, this one has been substituted for this, and now we are now having something like this. We are now having something like this, but I will draw it in ring form now. We are now having something like this. Let me draw it in ring form. I'll avoid wasting much of our time. So now this one. So instead of having one, the hydrogen is there, we are now having CH4. That's why it is now CH6H5. So hydrogen that's there, hydrogen, one hydrogen is here. Let me put that hydrogen. Hydrogen here. There's also hydrogen at the bottom here. Hydrogen here. But now this 1, 2, 3, 4, 5. Now one of the hydrogen has been replaced now. And so we call this one substitution. As I just want to emphasize that this is substitution. That's what I want to emphasize. Substitution has taken place. So the name, that what occurs here is substitution. So that's just the summary of it. Substitution, just like if I'm just trying to let you see what has taken place, so as not to avoid cramming words. So substitution reaction, basically the type of substitution reaction that takes place is alkylation. But substitution reaction is enough. Just like substitution reaction, they will give you your homework. So substitution reaction called alkylation, the addition of what? Alkyl group. Now, the next question is what? Look at this. This question is we are asked to what? Tell us the conversion that take place. Conversion that take place, that is NCl, NC2H4. These are these. You now have what? You now have C2 times H2. You put N now. Look at this. 18 and you put what is it? It's 18 and this is a monomer. We call it a monomer. That is because it's a single one. Monomer. Now it has become what we call this one is monomer. It is polarization monomer. Now whenever you wanted to produce a polymer, you try to what? The polymer is a result of connection of what? A long chain connection of carbon of small monomer. Like this, when 18 connected with each other, they form what we call polymer. And that polymer is a giant molecule. A giant molecule that is used for making plastics, rubbers, and so on and so forth. There are giant molecules that are used in industry, like for making a plastic bucket and so on. So even this PVC, polyvinyl chloride, is gotten from what? Polymer. So what is taking place here is polymerization. The process by which monomers come together to form giant molecules. You can see they are forming giant molecules. They will be connecting with each other. So and they will form polyethylene. This is ethene and this is called polyethylene. That's where the word polyethylene. Ethylene. That's what the polyethylene bag come from. We've heard about polyethylene bag. As a result of what? As a result of what? Of ethene combining together, and as it's combined together from giant molecules, so they could be able to make polyethylene bag that usually bag. So that's the one of the process here. The conversion that takes place is what we call polymerization. So polymerization is what? Is the conversion that takes place. Polymerization is the conversion that takes place. Now the next one is this. We have CH what? CH. CH3, CH2, C. Oh, so we have CH3, CH2, CH, into bracket COH, and CH3. We come in now, CH3, CH2. Now CH. Now we have that one. Now this CH now become double O. So CH3. Now something has taken place here. Now we have what OH here, and it's now becoming double bond. What O now? Oxidation has taken place. Oxidation has taken place. This is the process by which what oxidation has taken place. There is an addition of what? Oxygen that connects with what is. So that is oxidation. Oxidation. That and this is called oxidation. Oxidation has taken. That's the conversion that takes place. Oxidation, and it is called that conversion. This reaction is called carbonization. Reaction by which we form alkene. Alkene. So this is an alkene. You can see it having CHO, 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 CHO. So this is the functional group that is there. We call it alkene. So this is called oxidation. So the process by which alcohol, which is alkanol group, changes towards to alkene is what we call oxidation. Oxidation, specifically carbonization. So that is oxidation. That's oxidation reaction. Now this one is what? Look at this. We have some figure 4. We have something like this. we have CH2, double bond CH now. Going to look at this now. This is what we call addition reaction. You can see the double bond there has been lost, like it has been lost. One of the bond there has been removed. What causes is that there is an addition of hydrogen. When you add hydrogen to this is called unsaturated what? Now it has double bond, now it's called unsaturated. This one is called saturated. So now when you add what? When you add hydrogen to this, these two hydrogen like this will split in form of this. When you split like this one will connect with this one is your connect, that's why you have CH2, CH3. So what happens here is hydrogenation, addition of hydrogen. So we call it addition reaction. That is most unsaturated hydrocarbon that go with addition reaction, they can collect some things can add to them easily because they have a double bond. So addition, which is called what? Hydrogenation. That type of addition is called hydrogenation. That's going to talk about this compound one by one later in our subsequent videos. But these are just tips that will help you in exam when you are seeing something like this. So now that's that about this. And question E now says that what term is used to describe each of the following process? They have alkaline hydrolysis of fats. And I say alkaline hydrolysis of fats, it means that the addition of what? Of alkalis, that is basic, to what? To fat and oil. And that term is called saponification reaction. Saponification reaction is a very common question. You can see it in objective, you can see it in theory. The addition of what? Alkaline. Fat is written as well like this. Fat is like this CH2. Fat is a group that comes from esters. So fat comes from esters. So a branch esters is an ester group. You can see this ester group, functional group. So this fat come from the combination, a branch chain of ester group. So when you now add alkaline to it, alkalis, and you alkaline this fat and oil with sodium hydroxide or any base with sodium hydroxide, you're going to have what we call soap. That's why we call it saponification, because you get soap. So what we have here is we have CH. So this is how we get it. This we combine, we attach to this. This we attach to this. It's cut from here and it attach to this. This we come here and it will attach to this end. Then this OH now, it will now join this CH2. So you have OH here. Sorry for that, this one is OH, this one is OH. So that's what I should have done before. So this one will connect with this. So it means that now for them to connect now, this one must be 3. So 3 will enter here, 1 will enter here, 1 will enter here, 1 will enter, so will enter, it's connected. So you have RCOO, you have soap, then they have glycerol, but you are concerned about this soap. This is what we call saponification. So the term for an alkaline fat, this is fat, this is fat and oil, and this is what? Alkaline, alkalis. So that's alkalis. So that's why they call an alkaline fat. What do we term this process? This process is called saponification. Saponification. And the term process of what? The conversion of what? Of glucose into ethanol is what we call fermentation. So because of our time, it's called what? Fermentation. Fermentation. When you conversion of glucose into what? Into ethanol is what we call what? Conversion of what? Glucose. Glucose is 6,6 H what? H12O6. In the presence of what? In the presence of zymase. In the presence, that enzyme we are talking about, this enzyme. Then of zymase, we have what? 2H5O, that is ethanol, plus CO2. That's what we are going to have. So this is ethanol. This is ethanol. So we produce ethanol from what? From glucose. And when we produce ethanol from glucose, we call it what? Fermentation process. Fermentation process. Now, that's that about that. Now, the thermal decomposition of higher petroleum fraction in the presence of catalyst. The thermal decomposition of higher petroleum fraction. Whenever you are decomposing petroleum fraction into smaller what? Into smaller fraction, petroleum fraction into smaller beam. Especially when you are trying to convert the long carbon chain of hydrocarbon to smaller fraction in petroleum in crude oil station, we call that cracking. For that's one of the ways we turn a poor foil, a crude foil that is yet to purify has to undergo the process of cracking for it to be to become high performance foil. So when you break down petroleum fractions into the hydrocarbon in the presence of catalyst, is what we call cracking. This is called cracking. So I'm going to this is called cracking. We use it in purification of crude oil. Now let's do the calculation for this last one, and then we'll call it the day from here. So now, an hydrocarbon, look at this, is very important. An hydrocarbon Z. So an hydrocarbon is a compound of carbon and hydrogen, which is Z. An hydrocarbon Z, which contains what? Carbon and hydrogen. Please look at it. It contains carbon and hydrogen. So as what? As molecular mass of 78. That's molecular mass of 78. On combustion, 3.385 grams of CO2. CO2 now is 3.85 grams and 0.692 grams of water. Now water is 0.692 grams of water. Now determine the molecular formula of Z. Wow. Given that H is equal to 1, C equal to 12, oxygen is equal to 16. Now, how do you determine the molecular formula of this? So, it's very, very important that we know how to do this. Now, how do you derive its molecular formula? Now, the first thing is to know the percentage composition of carbon and hydrogen. What is the mass of carbon that essentially is carbon 4 oxide, and what is the mass of hydrogen? So what you now get is calculate the molecular mass of CO2. Molecular mass of CO2 is that's like it was this 12 plus 2 into bracket was 16. When you add it together, it becomes 12 plus this 12 plus 16 times 2 is 32 to give it 44 grams. Now the mass of carbon in this now will now be. Now carbon is 12. To be 12, carbon will now be mass of carbon. Mass of carbon now be 12 all over 44 times what? 0.85 gram. So my value is 0.9 is 0.93 gram. So the same thing is applicable to what hydrogen, getting mass of hydrogen. I just get the mass of water first. That is 2 in bracket 1 plus 16. So we have what? 18 what? 18 gram. When you have 18 gram, now, then you can now get what? Mass of hydrogen. So which is what? 2 bracket 1 over 18 times what? Times 0.692. So I multiply this one to give what? 0.077. So I haven't gotten the what? The mass of carbon and mass of what? This one is 7 gram and this one is 0.07 gram of carbon. So this is mass of what? Carbon 0.938 gram and this is mass of what? Hydrogen 0.077 gram. So you just write carbon hydrogen. That is the reacting masses now. Reacting masses. We have 0.938, 0.77 grams. So you divide by what? In empirical. To get the empirical, we divide by the relative atomic mass. It is 0.938 divided by 12. 0.077 grams divided by the atomic mass of C is 12, that's why it's 12. The atomic mass of hydrogen is what? 1. So we have what? So this one is 0.1. Press your calculator, you get 0.077. So you divide by the smallest. Divide by the smallest. The smallest. So we have 0.077, 0.077. This is 1 ratio what? 1. It means that this is 1 ratio 1. Carbon is what? Carbon to hydrogen is 1 ratio what? 1. So coming back to this piece now. Look at the arrow now. So since this is 1 ratio 1, your compound is CH1111. So now we have to calculate the molecular formula. In molecular mass is what? 78. Molecular is what? Molecular mass is what? 18 now. We have what? We now put 8 outside equal to 70 what? 8. Remember that your empirical formula is equal to what? Is equal to CH. Now the molecular formula, that's what we are looking for now. So this is the atomic mass of all this is what? 12 plus this one is what? 1 bracket n equal to 78. So 2 plus 1, 12 plus 1 is what? 13 and equal to 78. The value is by 13. This one. We have 6. So we have n equal to what? N equal to 6. So CH bracket what? CH bracket what? 6. We give what? 6 because it times this one. 6 is H6. This is benzene, which I drew for us the other time. This is benzene. Something like this. And since you draw the structure, this is benzene. This is benzene. So that's that. We have come to the end of the question and answer on organic chemistry. Please and please, if you have not subscribed to this channel, please press the subscribe button now and notification bell in order to see all our educative videos on this YouTube. Thanks for watching. God bless you. Amen.